moving on to the next center. So if you got that sheet yesterday, it's not really a cheat sheet. It's more just a sheet of all the vocab and all the terms. We are skipping down to the middle one that says angle bisector incenter, and then we're going to skip down to the last one, midsegment. So we're kind of skipping around on this sheet. But we are going to be doing two things in notes real quick, and then we're going to continue to work in that packet. So remember, you cannot lose this packet. You got to keep it, work on it, and near the end of the week we'll talk about what to do with it. Okay? So let's talk about angle bisectors and incenters. Okay? So we have another center. Let's recap yesterday. What center did we learn about yesterday? Centroid. And how do you make a centroid? With three what? There's a name for these lines. Okay, they connect a vertex and a midpoint, but what's that called? Medians. Okay, so this is yesterday. Look, medians make a centroid. Cool? So today, we're not talking about medians. We're talking about angle bisectors. Now, what does an angle bisector do to an angle? Cuts it in half. Okay? So, a triangle has three angles, so it has three angle bisectors. As you see in the picture here, angle bisectors give you equal angles, two equal halves, right? So you can show that with arcs. And I know no one's on our phone right now. Arc, arc, those match. Two arcs, those match. Three arcs, those match, right? So that's for sure an incenter, because I got three angle bisectors that cross at a point of concurrency that's called the incenter, point P. Okay? So again, angle bisectors make an incenter. And what we know about an incenter is that it is equidistant from the sides. Okay, so look at this picture right here. It tells us px equals py equals pz. So on the up here on the board, it's blue, but px, py, pz, those are all congruent. They're equal in their measurement. So I'm going to show that with tick marks. Px has a tick mark, py has a tick mark, pz has a tick mark. So go ahead and mark all those on there. And we're going to use that information to do the example problems at the bottom. Okay? So all we know so far is angle bisectors cut in half, right? And incenter is equal distance to these sides. So let's do number one. Okay, on number one, segments JV and KV are angle bisectors of triangle JKL. So that means this line right here cuts this angle in half. This right here cuts this angle in half. So ultimately, we're looking for VKL, which is way over here. But first, let's label what we know. Does everyone see VJL right here? This angle is 19 degrees. What else do we know because of that? If JV is an angle bisector, what do you know about these two angles? They're the same, right? If this is 19 degrees, this has to be 19 degrees because it was bisected. They have to be equal. So let's label that. This arc and this arc, these angles are equal. So I'm going to label 19 right there. Okay? Now, before I can get anything over here, I need to figure out what this big angle is. KJL, this big angle. I'm going to label it with a big arc. How many degrees is this big arc right here? What? How'd you get 38? Okay, part plus part equals whole. The angle addition postulate, 19 plus 19 is 38 degrees. So I labeled it right here. That this big angle is 38. Okay. So could you figure out WKL if you know this angle is 38 and this angle is 106? What do they always add up to? Triangle sum theorem says they always add up to 180, 180 degrees. So I'm going to write that as an algebraic equation. This angle I'm going to call Okay? So let's make my equation. My big angle over here, 38, plus my other angle, 106, plus x equals 180. And we can solve this, of course. We're going to combine like terms. 38 plus 106. 144 plus x equals 180. And then to get rid of that 144, we subtract. And we get x equals 36. Now, we need to find out if that's what we're looking for. So let's read our problem. Again, we skip down here, find the measure of angle VKL. So does everyone see VKL is actually this little angle right here? How am I going to figure out that little angle? Okay, since that's an angle bisector, I'm going to just divide it by 2, right? So I know we just said x equals 36. And to find each little angle, I'm going to divide by 2 and label little 18s right here and right here. Okay? And now we can answer. Angle VKL is 18 degrees. Right? So, you got to be able to do one of these on your quiz on Friday. So, again, if you know one little angle, the other one's the same because it's bisected. You can find the big triangle's missing angle and then divide that in 2 again. There's something we skipped over. Finding the distance from V to segment KL. From V to KL. Okay. So what I do is draw a little segment here. This is supposed to make a right angle. Now, do we know anything about from the center to the edge? What did we learn about from the center to the edge? Equidistant, right? They're equidistant. So from the incenter to the edge is always equal. So if from the incenter to W, if that's 7.3, what's from the incenter towards KL going to be? The exact same thing, 7.3, right? That's one of the properties of an incenter. It's equal distance to the sides. So that means I'm going to write my answer from V to KL is equal to 7.3. True. Okay, we're going to do another example like that. If you can flip it over. Same thing, different numbers. Here we go. All right, segments QX and RX are angle bisectors. So again, angle bisectors means it's an incenter. So I'm going to skip down. We are looking for PQX, which is right about here. So I'm going to have to do something with what I know. So what should I label first? What angle? What angle? XR what? Okay, XRY is 12, right? What else do I, what can I label? XRQ up here is also going to be 12, okay? So let's label that. If both of those halves are 12, what's the whole angle YRQ? 12 plus 12. So yeah, we get 24. So I've got my big angle on the right. QRY is 24. And I got my other angle, 52. I can find my missing angle because they add up to 180. So this angle over here, let's label it. I'm going to give it the variable Z, only because X and Y are taken on the picture. And I'm going to set up an equation. So here we go. 24 plus 52 plus my missing angle Z has to equal 180. We'll combine like terms. So 76 plus Z equals 180. And then we get rid of our loaner, and we get Z equals 104. So if Z equals 104, we can write that up here. Now, we're not looking for that whole angle. We're just looking for PQX, which is right here. So what do I need to do with 104? Divide by 2. So 104 divided by 2 is 52 degrees. So angle PQX equals 52 degrees. All right. Now, that's it for incenters or the incenter and angled bisectors. The other sheet, we're going to do that right now, midsegment. So let's go ahead and go to the next sheet you picked up on the way in, midsegment notes. What do y'all think this looks like right here out of some weird video game? The Legend of Zelda, what's that? Okay, so the Triforce, power, courage, wisdom. All right. Right. Zelda's the princess, not the dude with the green spandex, right? Or whatever. By the way, I have beaten every single canon game in the Legend of Zelda franchise. And I'm also wearing a raccoon hat, so. A Tanuki Mario hat. All right, so let's do midsegments. A midsegment of a triangle. By the way, the word midsegment tells you exactly what it is. It's a segment that connects mid points. Midsegment, okay? So y'all see that over here in this picture down here? DE, this blue line from D to E, those are both midpoints, and that's a segment. Midsegment. So if I make 3 midsegments, you're going to make a midsegment triangle within another triangle, which again, we've seen before. So you need to know the relationship for midsegments, okay? So check it out. Oops. Down here. This says DE equals 1/2 AC. Has everyone seen that? DE, the midsegment, equals half of the outside parallel side AC. Okay, so I'm going to write that in my own words right here. Midsegment equals half of side. And just that information can open up a world of possibilities that we're going to try down here on number 1 and 2. So a midsegment is half of a side. So let's look at number 1. You should be able to do 2 things. Given a midsegment, give me the side, and given the side, give me a midsegment. Okay? So let's start with UV. I know UV is 5.2, right? So the parallel side down here is RT. Now, if I know UV is 5.2, and I know that's supposed to be half of the side, how am I going to figure out RT? That's it. Multiply by 2. So I'm going to kind of show my work here. 2 times UV equals RT. Okay? Which means 2 times 5.2, and that gives me 10.4. Okay? That's if you're given the midsegment, you can find the missing side. Right? Now, what if I have the side? So look at ST. If I know ST is 7.4, how am I going to figure out UW, which is what I'm actually looking for? How do I go from side to midsegment? Divide by 2. Okay, working backwards here. So, again, if you know the side, the midsegment is half. So 1/2 of ST is going to give me UW. So 7.4 divided by 2 will give me my answer. 7.4 divided by 2 is 3.7. So up here I put 3.7. Now, that's just finding missing sides. We skipped over one thing, or we need to do one more thing. Find the measure of angle SVU. Right here, S to V to U. Now, the only angle that's labeled is what? 41. So here's my question. What's the relationship between 41 and SVU? We did a unit on angle relationships with parallel lines cut by a transversal. Do y'all remember alternate interior angles? Do y'all remember if they're congruent or supplementary? Congruent. So check it out. VUW, angle 41, and UVS, or SVU, these are alternate interior angles, and they are also congruent. So the missing angle is 41. So let's write our answer. Angle SVU equals 41 because they're alternate interior angles. True? True. All right, number 2 says find the perimeter of the midsegment triangle. What are the 3 vertices of the midsegment triangle? Hint, they're midpoints. What are the 3 vertices, the corners of the midsegment triangle? K, M, and L, or KLM, whatever. Okay? It's the triangle within the triangle. They want to find the perimeter of that. And we know perimeter means add up all the sides, right? So I only have one side on the inside, 7. But I can figure out these missing ones. So let's start off with GH is 12. How am I ever going to figure out ML? What do you think? If I know the side, how do I get the midsegment? Yeah, how do you go from the side to the midsegment? Divide by 2. Okay, thank you. Right? So, 12 divided by 2 is 6. Now, I also need to find Km. How am I going to find Km if I don't know HJ? Well, I know half of HJ, so LJ is 4. So 2 tick marks is 4, so this one's also going to be 4. The whole thing is 8. And then half of 8 for Km is 4. Okay? Now, do y'all notice how there's 3 4s here? Don't tell Jeff Davis. The 4 guy. That's where you can call and get some help. You can stop and get some help. All right, so 4, 4, and 4. So if this is 12, and we know this is cut in half, there's 2 6s here. So again, we have 3 of the same number, and then if this is 7, these are also both going to be 7. And total right there is going to be 14. So no matter what number it is, we do have 3 of them when we're talking about mid-segments. Okay? So do you see how that works? Flip it over. Now, somebody wanted to know, oh, by the way, wait, unflip it over. Edit, undo. Go back. We forgot to actually answer number 2. It says find the perimeter, so now we got to do the perimeter. So the perimeter of the midsegment triangle is adding up what 3 sides? 4 plus 6 plus 7 is 17 units. All right, now you can flip it over, please. On the back, somebody conveniently put a triangle inside of a pond. It happened randomly that there would be a triangle sticking out of a pond and that they would ask to find out the distance across the pond from X to Z. Right. So from X to Z, I'm going to label that V, just because that's the variable we're not using yet. So how do I figure out this distance if the midsegment is 39? Okay, I'm going to take that midsegment and times it by 2. So 39 times 2 is 78 meters. Okay. Any questions on that? If you've got a midsegment, to find the side, you just multiply it by 2. All right, let's look at the next one, number 4. So we have a midsegment and a side. What do we know about the midsegment and the side? What's their relationship between each other? We don't know. How much do I multiply the midsegment by to get the side? Times 2. So we're just going to do midsegment times 2 equals side. Here's how I would write it. 2 times midsegment equals side. And then I'm going to replace midsegment with 2x and side with x plus 12. All right. And now we can solve this. What's 2 times 2x? 4x. And then, to get rid of my smaller x, I subtract x. And then I divide by 3, and I get 4. Now, 4 is not the answer that I'm looking for. I'm looking for DE, right? So DE is 2x. 2 times x, which is 4. So 2 times 4 is 8. My DE is 8. Cool? All right. Last one here. I want you to plot these 3 points right now. Do it, do it, do it. All right. So I'm going to plot these 3 points. Plot, plot, plot. And I'm going to connect them. Connect, connect, connect. Label, label, label. And everyone's doing this with me? So we need to find the midsegment of BC. So that means for BC, midsegment's going to be like right here somewhere. I need to find, for a midsegment, I need to find midpoints. So the midpoint of AB, from A to B, that's 6 units across. So I go over 1, 2, 3, go straight up, put a point right there. For AC, that's 2 units left and right. So I go over 1, straight up, put a point. And connect those with a very long line. I want you to make your midsegment go far, farther than the triangle. Look like this. Okay? Here's why. That midsegment is part of a line, and that line has a equation. Y'all like this? Y'all's favorite thing from Algebra 1? Y equals mx plus b, right? I know you can give me an equation of that line, right? Let's remember, y equals mx plus b is the format. M stands for what over what? Rise over run. So let's rise and run for this midsegment. How much does it rise? How much does it rise? 2. How much does it run? 4. 2 over 4 reduces to 1/2 x. And then plus b, what does b stand for? Where does it cross the y-axis? At 5. So 1/2 x plus 5 is the equation of my midsegment parallel to BC. All right? Now, we finished 3 notes in 2 days, and you have all your assignments connected. So now you're able to do page 2 and 3 of your assignment packet. Okay? Cool? So again, that's what I want you to work on right now. Okay, we're going to do the other 2 notes tomorrow. We'll have a day to work on Thursday, and then we're quizzing on Friday. But you do have time right now, so I want you to finish the first 3 pages. You can do it. Go.